Hello my schoolers, you are welcome to my school channel and my name is Frank. In this video, we are going to be tackling JAMB CBT physics past question for the year 2023. Please do not go anywhere, stay with us, we'll be right back. Welcome back to my school channel. In this video, we are going to be answering question 21 to 40. So let's begin with question 21. What is the amount of heat required to raise the temperature of a 0.02 kg of ice cube from minus 10 degrees Celsius to 10 degrees Celsius? So we are given this information. Specific latent heat of fusion of ice to be equals to 3.34 times 10 raised to the power 5 joule per Kelvin. Specific heat capacity of water to be equals to 4,200 joule per kg per Kelvin, while specific heat capacity of ice to be equals to 2,100 joule per kilogram per Kelvin. So let's move over to the board to solve this question. So to solve this question, we actually need to calculate for 3 things. Then we add together to get the final answer, because we are asked to calculate the amount of heat required to raise. Okay. So let's begin. So first of all, first thing we have to calculate for, the quantity of heat. So let's put it like this: the quantity of heat required to raise the temperature, okay, of ice, of the ice cube from minus 10 degrees Celsius to 0 degrees Celsius. Okay, I will know that heat capacity is equal to H is equals to MC, then change in temperature. So let's put in our values. So mass of the ice cube is 0.02 times specific heat capacity of ice. So the specific heat capacity of ice is given to us 2,100, then times change in temperature. Okay, so we are moving from minus 10 degrees Celsius to 0 degrees Celsius. So in this case, we are going to have 0 minus 10. Okay, 0 minus 10. So this becomes 0.02 times 2,100 times 10, because minus times minus is plus. Okay, so 0 plus 10, which is also 10. So this will be equals to 420 joule. Okay, so next we calculate for the quantity of heat required to melt ice. Okay, to melt ice at 0 degree. Okay, and that will be equals to H is equals to ML, where L stands for latent heat of fusion of the ice. So we still put in our value. So this becomes 0.02 times, that is given to us to be 3.34 times 10 raised to the power 5. Okay, so if we multiply this out, this will be equals to 6,680 joules. Okay, then next we calculate for the heat, or the quantity of heat required to raise, okay, the temperature of the melted ice, melted ice from 0 degree to 10 degrees Celsius. But one thing you must know, that the melted ice is already water. Okay, so we are now using H is equals to MC, then change in temperature. Okay, so our M still remains 0.02 times, in this case we are using specific heat capacity of water, okay, which is 4,200, then times the temperature change, which is 10 minus 0. Okay, so this becomes 0.02 times 4,200 times 10, and this will be equals to 840 joules. Okay, so the amount of heat required to raise the temperature of 0.02 kg of ice cube from minus 10 degrees Celsius. 10 degrees Celsius will now be equals to the summation of all the heats, okay, of all the values that we got from the calculation of all the heats. So that would be 420 plus 6,680 plus 840. So if we adding this together, that will give us 7940 joule. So let's move over to the screen to pick the correct option. Okay, so from our calculation, we got 7,940 joules. Okay, so, and that makes option D the correct answer. Question 22. Which of the following thermometers measures temperature from the thermal radiation emitted by object? So A, we have pyrometer thermometer. B, we have platinum resistance thermometer. C, we have thermocouple thermometer. And D, we have constant pressure gas thermometer. So the answer to this question is option A, pyrometer thermometer. Okay, so pyrometer thermometer is a type of remote sensing thermometer used to measure the temperature of surface. Okay, and it does this by measuring the thermal radiation emitted from a body. Okay, so that makes option A the correct answer to this question. Question 23. A 400 Newton bus is being pulled along a level floor at a constant speed by a force P of 100 Newton at an angle of 30 degrees to the horizontal, as shown in the diagram above. What is the coefficient of kinetic friction between the bus and the floor? So let's move over to the board to provide solution to that question. So there are a lot of forces that are acting on this board. So let us specify them. Okay, so first of all, there are two forces acting here. This force P, okay, so we have to resolve this into x and y component. Okay, but since this is in first quadrant, so it's very easy to resolve. So Px, the horizontal component, is equals to, in that case, become P cos theta. Y for the y component becomes Py is equals to P sine theta. Okay. Now, apart from that, we also have normal reaction, okay, that is also acting against the bus, that is acting on the bus. So let's call that arrow. Okay, then the weight of the bus too, that is acting downward. Okay, let's call it W. Okay, then we also have frictional force, okay, that is resisting the movement of the force. Okay, the movement of the bus. Sorry, so that force is acting backward. Okay, so let's call it F arrow. Okay, but remember that F arrow is equals to coefficient of limiting friction times normal reaction. Okay, so if you check very well, there are two horizontal forces that are acting against this, that are acting on this bus, which is Px and F arrow. Okay, so in order for this bus to move, okay, then Px must be greater than F arrow, so that Ps minus F arrow is equals to Ma. Okay, but in the question we are told something about constant speed. Constant speed. So when speed is constant, in that case A is going to be 0. So here we'll be having Px minus F arrow is equals to 0. Okay, because mass times 0, since acceleration is 0, then mass times 0 will be equals to 0. Okay, so let's put in our values. So we already know what our Ps is, which is P cos theta. Then we can just move this to the other side. But we know that our F arrow, which is the frictional force, is equals to U times arrow, okay, which is U arrow. Now for the horizontal forces, okay, we have Py, we have W, which is weight of the bus. Then we also have our normal reaction. Okay, so that Py plus W should be equals to arrow. Okay, because they are acting opposite to each other. So our Py is P sine theta, then plus, we already know our weight, the weight of the bus, which is 400 Newton, which is equals to our R here. Okay, but we know P. So P is equals to 100, then sine 30 plus 400, and that is equals to R. So that sine 30 is actually 0.5. So 0.5 times 100, that will give us 50, then plus 400, that will give us arrow. So that arrow is equals to 450 Newton. Now that we have gotten the value of R, then we can now move it, we can now return back to the horizontal component. Okay, so from the horizontal component, we know that P cos theta is equals to our coefficient of limiting friction times the normal reaction. But P is equals to 100, and here is cos 30 is equals to U. But our normal reaction is 400, so we'll put it here. So since we are looking for the coefficient of limiting frictional force, so that it becomes 100 cos 30 divided by 450, and this will be equals to 0.19. Okay, it doesn't have a unit because it's a ratio. Okay, so let's move over to the screen to pick the correct option. So from our calculation, we got the coefficient of kinetic friction between the balls and the floor to be equals to 0.19. So that makes option A the correct option. Question 24. Light of wavelength 589 nanometer in vacuum passes through a piece of fused quartz of index of refraction N is equals to 1.458. What is the frequency of the light in fused quartz? Speed of light is given to us to be equals to 3.00 times 10 raised to power 8 meter per second. So let's move over to the board to solve that question. So everything we have here are the information that is given to us in the question. Okay, and these are the information that we need to be able to solve these questions. Okay, so our lambda here, okay, our lambda V here subscript V stand for the wavelength of light in vacuum. Okay, while our V subscript V here stand for the speed of light in vacuum. So our lambda M here stand for the wavelength of light in material, speed of light in material. Okay, so first of all, we need to calculate for the wavelength in material and also calculate for the velocity of light in material. Okay, but we know that wavelength in material, okay, will be equals to wavelength in vacuum divided by the refractive or the index of refraction N. Okay, so we just substitute our value, so that will give us 589 divided by 1.48. Of course, remember that this is given to us in nanometer. Okay, so this will be equals to 404 nanometer. Okay, so we also do the same thing for the speed of light. Okay, for the speed of light in material, which is Vm is equals to, of course, the speed of light in vacuum all over the index of refraction. So this will be 3.00 times 10 raised to power 8 divided by 1.458. And this will be equals to 2.06 times 10 raised to power 8 meter per second. Okay, remember that velocity, the unit of velocity. Now we are calculating for frequency in the medium. But remember that frequency does not change. Okay, when a light wave travels from one medium to another, the frequency still remains the same. Okay, so remember that V is equals to F lambda. Okay, and we already know lambda. Everything we are using here, all the information we are using here has to do with the materials. So this is speed in material, and this is lambda, the wavelength, also in material. So in this case, since we are looking for F, then we just divide both sides by lambda. So we are having Vm all over lambda M. So we put in our values. Okay, so for our first value for Vm, we actually got 2.06 times 10 raised to power 8, then divided by 404. Okay, of course this is given to us in nanometer, so we have to convert it to meter by timesing by 10 raised to power minus 9. Remember that 1 nanometer is equals to 1 times 10 raised to power minus 9. Okay, so if we divide this, so we'll be having 5.09 times 10 raised to power 14 hertz. Okay, so let's move over to the screen to pick the correct option to this question. Okay, so from our calculation, we got 5.09 times 10 raised to power 14 hertz. Okay, that makes option B the correct option. Question 25. A simple pendulum has a period of 5.77 seconds. When the pendulum is shortened by 3 meters, the period is 4.60 seconds. Calculate the new length of the pendulum. So let's move over to the board to solve that question. So from that question, we are given this information, okay, but we don't know the original length. So we say let the original length of the pendulum be x, so that the new length becomes x minus 3. Okay, because in the question we are told that it was shortened by 3 meters. Okay, so we know that t is equals to 2 pi root L all over G. So from here we can get that T1, okay, this is T1 square all over L1 is equals to T2 square all over L2. So we just substitute our the given information into this equation. So we know that this is 5.77 square all over the original length, which is x, is equals to, here is 4.60 square all over L minus 3, okay, in bracket. Okay, we can as well still remove the bracket. So we cross multiply. So, but 5.77 square is equals to 33.29, okay, all over x. And 4.60 is equals to 21.16 all over x minus 3. So we cross multiply. So this will give us 33.29x minus 99.87 is equals to 21.16x. So we collect like terms. 33.29x minus 21.16x is equals to 99.87. Okay, so if we subtract, this will be equals to 12.13s is equals to 99.87. So we divide both sides by the coefficient of x to get the value of s. So x is equals to 99.87 divided by 12.13, and that will be equals to 8.23, okay, meter. Now that I've gotten the value of x, but we are asked to find the new length, okay, and this is the new length. So this is L1 actually, why this is L2, okay, so this is the new length. But the new length is, L2 is x minus 3, okay, but the value of s is 8.23, so we just substitute here. So that will be 8.23 minus 3, and this will be equals to 5.23 meter, okay. So the value of the new length is 5.23 meter. So let's move over to the screen to pick the correct option. So from our calculation, we got the value of the new length to be equals to 5.23. So that makes option A the correct option. Question 26. 3 forces with magnitude 16 Newton, 12 Newton, and 21 Newton are shown in the diagram above. Determine the magnitude of the resultant force and angle with the s-axis. So let's move over to the board to solve this question. So in this question, we'll have to resolve these forces into the x and y component, okay, to be able to answer that question. So let's do just that. Okay, let me open this place up a little. So these are our s components. So just take note of that. Why these are our y component? Okay, so the first force there, let's start with Newton, 12 Newton, then 16 Newton, then 21 Newton. Okay, so to resolve this into the s component, actually we're actually looking for this part. Okay, so you can do something like this. So this place is opposite here, so they are the same. So this is your y component for this part. So we are going to resolve this force into x and y component, but we know that this is in the first quadrant. Okay, 32 is in the first quadrant, so it's very easy. So here you just go 12 then cos 32 degree. Okay, why here you go 12 sine 32 degrees. So they are all positive. Sine and cos here is positive. Okay, then we'll move to the second force, which is 16. So you can as well still do this. Okay, so this is opposite this, so they are equal. So this is your y here is your s. But in this case, this is your negative s direction. So your s is going to be negative. Okay, so this will be minus. Of course, we still do the same thing, we're still having the same thing. So this will be minus 16 cos 26. Y here will be positive, which is 16 sine 26. Okay, y is positive here. So let's move down to this. Okay, so since we know that from this point to here is 90, okay, we still apply the same rule. So we take here the angle here to be equal to 90. Okay, so but our s here is actually going to be 0. So here we are going to be having 21 cos 90 degree While here we are going to be having minus 21 sine 90 degree. Okay, so if we resolve this, if we total this here, we'll be having minus 4.20 Newton. Okay, use your calculator to sum all this up. That will give you minus 4.20 Newton. While here we give you 7 minus 7.63 Newton. Now, all this minus, they are just telling you about direction, really. So they don't affect anything. They are just telling you that, okay, what you did, this is going to be in the negative y direction. Why this is going to be the negative s direction. So let's draw our angles now. So let's draw our right angle triangle. So this our right angle triangle is going to be like this. This is our negative s direction, and this is our negative y direction. So we'll be having this. But we are told that the angle is formed between the s axis. So this is where theta is going to be. Y here is 7.63. Y, this place gives us 4.20 Newton. Okay, but we are looking for here, which is the hypotenuse of this right angle triangle. So here we simply apply Pythagoras theorem to get the value of the magnitude of the force. So let's call it x. Okay, so applying Pythagoras theorem, we'll be having s squared is equals to 7.63 squared plus 4.20 squared. Now, you don't need to bring in this minus here. I told you the essence of this minus just to tell you direction. Negative y and negative x. Okay, so that s is equals to square root of 7.63 squared plus 4.20 squared. Okay, so this will be equals to 8.71 Newton. Okay, so the magnitude of the force is equals to 8.71 Newton. But we need to also calculate the direction of the magnitude of the force. Okay, so here, since we know that this is the angle we are looking for, and here is opposite, and here is adjacent. So in that case, we are going to be using tan. So here we'll be having tan theta is equals to 7.63 all over 4.2. Okay, so this will be equals to, so theta will be equals to tan, okay, tan inverse of 7.63 over 4.20. So this will be equals to 61 degree. Okay, so let's move over to the screen to pick the correct option. Okay, so from our calculation, we got the magnitude of the resultant force to be equals to 8.71 Newton, while the angle with the s axis to be equals to 61 degree. So that makes option B the correct option. Question 27. A traveling wave of amplitude 0.80 meter has a frequency of 16 Hz and a wave speed of 20 meter per second. Calculate the wave number of the wave. So let's move over to the board to solve that problem. Okay, so we know that from wave motion, okay, k, which is given as wave number, is equals to 2 pi all over lambda. Okay, but in the question we are given velocity to be equals to 20 meter per second, which is speed of the wave to be equals to 20 meter per second, and we are given frequency to be equals to 16 Hz. So from there we can calculate for wavelength, okay, which is not given to us in the question, but we know that V is equals to frequency times wavelength. So we can make wavelength subject of formula, so that wavelength is equals to speed divided by frequency. So we put in our value, that will be 20 divided by 16. Okay, so this will be equals to 1.20 meter, okay, for wavelength. So we just carry this value and substitute into the original equation, okay, which is the wave number. So we know that pi is usually 3.142 divided, in this case, divided by 1.20. So this will give us 5.2. Okay, so to the nearest whole number or to one significant figure, our value will be equals to 5. Okay, so let's move over to the screen to pick the correct answer to the question. Okay, so from our calculation, we calculated the value of the wave number of the wave to be equals to 5. So that makes option C the correct option. Do you know that you can take practice question with our simulated JAMB CBT past question? All you need to do is to click on the link in the description below, and this will take you to Myschool website. There you have to download Myschool mobile app for your Android devices and Myschool software for your laptops and computer. Please Go ahead and start practicing. Moving on to question 28. The near point of a patient's eyes is 50.0 centimeter. What power in diopter must a corrective lens have to enable the eye to see clearly an object 25.0 centimeter away? Okay, so what this question is telling us that there is a patient and this patient cannot see any object clearly that is less than 50 centimeter away from his eyes. So they are now asking us what power in diopter can the patient use to enable him or to enable the patient to see clearly an object placed 25 centimeter away from his eyes. Okay, so let's move over to the board to solve that question. So we know that power of lens is given as 1 all over focal length. Okay, power of lens is given as 1 all over focal length. So from the information that is given to us, we know that U is going to be equals to 25 centimeter. So that our V is going to be minus 50 centimeter. Okay, remember this is virtual image. Okay, so in order for the person to see, for the patient to see an object placed 25 centimeter away from his eyes, okay, the image of that object has to form 50 centimeter in front of the lens, okay, that is going to be using. So using our lens formula, 1 over F is equals to 1 over U plus 1 over V. Okay, so 1 over F becomes 1 over 25 minus, okay, because minus is stronger than plus, so 1 over 50. So that 1 over F is equals to 2 minus 1 all over 50. So which is 1 over 50. So here F becomes 50 centimeter. Okay, which is the same, which is equivalent to 0.5 meter. So now that I've calculated for the value of the focal length, then we just substitute it into our original equation. So here we'll be having 1 over 0.5. So this is equals to 2 diopter. 2 diopters. So let's move over to the screen to pick the correct option. So from our calculation, we got 2 diopters. So that makes option A the correct option. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos. Question 29. Which of the following is / are not true about the heat capacity of a substance? I, it is an intensive property. Its SI unit is joule per Kelvin. it is an extensive property, while IV, its SI unit is joule per kilogram. Okay, so heat capacity is defined as the amount of heat required to raise the temperature of an object by 1 degree Celsius. Okay, and its SI unit is joule per Kelvin. Okay, heat capacity actually is an extensive property because it depends on the mass of the system. Okay, so that makes option D the correct option. II and III only. Those are the two statements that are true of heat capacity. Question 30. The pinhole camera works on A, the principle of the reversibility of light, B, the principle of the rectilinear propagation of light, C, the Huygens principle, D, the principle of total internal reflection of light. So the pinhole camera works based on the fact that light travels in a straight line. And this principle is what is referred to as the principle of rectilinear propagation of light. Okay, so when a light from an object passes through the pinhole of a pinhole camera, an inverted image of the object is formed on the opposite side of the camera. So that makes option B to be the correct option, the principle of the rectilinear propagation of light. Question 31. A step-down transformer is used on a 2.2 kilovolts line to deliver 110 volts. How many turns are on the primary windings if the secondary has 25 turns? So let's move over to the board. So remember that for a step-down transformer, okay, step-down transformer is used to step down high voltage in the primary winding, okay, to low voltage in the secondary winding. Okay, so these are the information that is given to us. So the EMF, okay, in the primary winding is equals to 2.2 kilovolts, which we can convert to volts by simply multiplying this by 1000. Okay, so if we multiply this by 1000, we're having 2200 volts. Okay, while the EMF in the secondary winding is equals to 110 volts. Now we are asked to calculate for the number of turns in the primary winding, where we know the number of turns in the secondary winding. Okay, so we simply use Px. Okay, EP is equals to Ex over MP is equals to over Nx. So we just put in our values. So EP is 2200 over MP, what we are looking for, we don't know, is equals to ES 110 over NS is 225. So we just cross multiply so that 110 MP is equals to 2200 times 25. Okay, so this 0 can take this 0 away, so that MP is equals to 220 times 25 divided by 11. So 11 here is 1, 11 into 22 is 2. So that we'll be having 20 times 25. And this will be equals to 500 tons. Okay, so on the primary winding, we have 500 tons. So let's move over to the screen to pick the correct option. So from our calculation, we got 500 windings on the primary turn. So that makes option D the correct answer, 500 tons. Question 32. A block of mass 0.5 kg is suspended at the 40 centimeter mark of a light metal rule AB that is pivoted at point E, the 60 centimeter mark, and is kept at equilibrium by a string attached at point D, the 60 centimeter mark, as shown in the figure above. Find the tension in the spring. Take G to be equals to 10 meter per second square. So let's move over to the board to solve this question. So this is the question that is given to us. Okay, and we are asked to calculate tension here. Okay, so first of all, what we need to do here is to calculate for the weight of this mass. Okay, so weight is equals to mg. So that in this case, we'll be having 0.5 times 10, and that will give us 5 newtons. So this weight is acting downward. So we need another weight that will act upward so that we can apply the principle of moment. Okay, now we have to resolve this tension here, okay, into horizontal and vertical component. Okay, so if we resolve this tension into the vertical component, because that's what we need, not the horizontal component. So that will be equals to, let's call it Ty will be equals to T sine 30 degree. Okay, so now we have to apply the principle of moment in order to be able to get the value of the tension in the spring. Okay, now taking moment about this point, remember that moment means force times perpendicular distance. So taking moment about point E, here we'll be having that our weight, which is 5 newton, and the distance between the point where the weight was earned to the point where we are taking the moment to be equals to 50, which is 90 minus 40. So that will give us 50. So moment about E, then this becomes 5 times 50. And this must be equals to, of course, the moment that we are going to be taking here. So considering our vertical tension here, okay? So the tension is at 0.60 centimeter. So the distance between 60 centimeter to 90 centimeter will be equals to 30. So here we'll be having T sine 30 times 30. So if we multiply this will give us 250 is equals to T, and sine 30 is the same thing as 0.5. So we'll be having T times, which is 1 over 2, okay, times 30. So that here will give us 15. So that 250 is equals to 15T. So to get the value of T, we just divide both sides by 15. So that T is equals to 250 divided by 15. So we can divide gradually. But if we divide, this will be equals to 16.67 Newton. Okay, so the tension in the spring is equals to 16.67 Newton. So let's move over to the screen to pick the correct option. So from our calculation, we calculated the tension in the spring to be equals to 16.67 16.67 Newton. So that makes option A the correct option, 16.67 Newton. Question 33. A 35 kilo ohms is connected in series with a resistance of 40 kilo ohms. What resistance R must be connected in parallel with the combination so that the equivalent resistance is equal to 25 kilo ohms? So let's move over to the board to solve that problem. So we are told that the first resistor, okay, has a resistance of 35 kilo ohms, while the second one has a resistance of 40 kilo ohms. And we are also told something about the equivalent resistance to be equal to 25 kilo ohms, that we should calculate that other resistance that we need to add, okay, so in order to arrive at this value, okay. But we know that effective resistance or equivalent resistance in series, okay, equivalent resistance in series, okay, is equals to R1 plus R2. So in this case, we just add those two together, which is 35 plus 40, okay, and that will give us 75 kilo ohms. Okay, so that is the equivalent resistance in series. But we are told that this resistance is connected in parallel, okay, with a third resistance in order to get the equivalent resistance of 25 kilo ohms. Okay, so, but we know that equivalent resistance, okay, in parallel, equivalent resistor in parallel is equals to 1 over R equivalent resistance in parallel all over 1 is equals to, 1 over R. Okay, in this case, let's call this R4. Okay, let's call this R4. It's equals to R4 plus 1 over R3. Okay, so we're actually looking for this value. Okay, so and we know this value. So let's put in the value. So here is 1 over 25 is equals to 1 over 75 plus 1 over R3. Okay, so R3 is actually the resistance that we are looking for. So we just collect like terms here. These two are like terms, so we move this to the other side. So that we'll be having 1 over R3 is equals to 1 over 25 minus 1 over 75. So we simply take the SCM of this, and the SCM of this is 75. Okay, so 25 is 75, that will be 3. 3 times 1 will be having 3 here, minus the 71 is 71, that will still give us 1. Okay, so that let's continue from here. Okay, let's continue from here. So that we'll be having 1 over R3 is equals to 2 over 75. So this becomes 2R3 is equals to 75. So to get the value of R3, we divide both sides by 75. So divide this by 2. And this will give us 37.5 kilo ohms. Okay, so the third resistance that we need, okay, that must be connected in series to the first two, so that the effective resistance can be equals to 25 kilo ohm is 37.5 kilo ohms. So let's move over to the screen to pick the correct option. Okay, so from our calculation, the value of R that we are looking for was 37.5. So that makes option B the correct option. Question 34. A piano wire 50 centimeter long has a total mass of 10 gram and it's stretched with a tension of 800 Newton. Find the frequency of the wire when it sounds its third over 2 note. So let's move over to the board. So these are the information that are given to us according to the question. So these two quantities we have to convert into their basic unit. Okay, so we convert centimeter to meter by dividing by 100, and that will give us 0.5 meter. And we convert gram to kilogram by dividing by 1000. That will give us 0.01 kilogram. Okay, so fundamental frequency, we can calculate fundamental frequency using 1 over 2L, then root T all over mu. Okay, but mu is equals to mass all over length. So let's substitute this value to get the value of mu. So that will give us mass is 0.01, okay, over the length is 0.5. So if we manipulate this will give us 0.02. Okay, so now that I've gotten the value of mu, we just substitute it into this equation. So fundamental frequency is equals to 1 over 2 times 0.5, then root 800 over 0.02. Okay, so if we multiply out here, that will be equals to 1, so we don't need this part again. Okay, 2 times 0.5 will be 1. 1 divided by 1 is still 1. 1 times anything still remains that thing. Okay, so 800 here divided by 0.02, that will be equals to, we're still having roots, that will be equals to 40,000. Okay, 40,000. So we simply take the square root of 40,000 to get the fundamental frequency. Okay, and that will be equals to, taking the square root of 40,000, that will be equals to 200 Newton. Okay, but in the question we are asked to calculate the frequency of the wire when the sound is 10 over 2 notes. So 10 over 2 notes, 10 over 2 notes, okay, is equals to 4 times fundamental frequency. Now, since we have gotten the fundamental frequency to be equals to 200 hertz, not Newton, 200 hertz, then we simply substitute. So here we'll be having 4 times 200, and this will be equals to 800 hertz. Okay, 800 hertz. So let's move over to the screen to pick the correct option. Okay, so from our calculation, we got 800 hertz, and that is option A. So option A is the correct option to this question. Question 35. An object is placed 35 centimeters away from a convex mirror with a focal length of magnitude 15 centimeters. What is the location of the image? So let's move over to the board to solve that question. So using our mirror formula, where 1 over F is equals to 1 over U plus 1 over V. Okay, but we are told in this question that the focal length is equals to 15 centimeters and that the object distance U is equals to 35 centimeters. Okay, but one thing that we must remember here is that the focal length of a convex mirror, okay, is negative, so that our F is actually minus 15 centimeters, and we are asked to calculate the image distance. Okay, so we just substitute our the given data into our formula. So here we'll be having 1 over minus 15 is equals to 1 over 35 plus 1 over V. So we are calculating for V. Okay, so we just collect like this, so that 1 over V is equals to minus 1 over 15 minus 1 over 35. Okay, so solving this, we'll be having that 1 over V is equals to minus 2 all over 21. Okay, so that V is equals to 21 minus 21 divided by 2. Okay, and this will give us 10.5 centimeter minus 10.5 centimeter. So what the negative sign here means is that the image is formed behind the mirror. Okay, so let's move over to the screen to pick the correct option. Okay, so from our calculation, we got the location of the image to be 10.5 centimeter. Okay, but our calculation, we got a negative value. So that negative value indicates that the image is formed behind the mirror. So that makes option B the correct option. 10.5 centimeter behind the mirror. Question 36. A relative density bottle has a mass of 19 grams when empty. When it is completely filled with water, its mass is 66 grams. What will be its mass if completely filled with alcohol of relative density 0.8? So let's move over to the board. Okay, so we know that the mass when it's empty, the mass of the bottle when it's empty is 19 grams according to the question. When it is filled with water is 66 grams. So from there we can actually get the mass of water. Okay, since we know that the mass of the bottle plus the mass of water equals to 66 grams, and we know that the mass of the bottle is 19 grams. Okay, so we can actually make the mass of the water the subject of formula so that we can get the mass of the water. So that will be 66 minus 19. Okay, and that will be equals to 47 grams. So we already know the mass of the water to be 47 grams, but we don't know the mass of alcohol. Okay, but we're only given the relative density of alcohol, and we know that relative density, okay, of alcohol in this case will be equals to mass of alcohol, okay, mass of alcohol over mass of an equal volume of water. Okay, equal volume, okay, of water. not to waste our time. So we just substitute the given value. So relative density of alcohol is given to us to be 0.8. Mass of alcohol, we don't know, MA. Then over mass of an equivalent of an equal volume of water, which is 47. Okay, so we can just cross multiply to get the value, to get the mass of the alcohol. So that would be MA is equals to 0.8 times 47. And this will be equal to 37.6 gram. Okay, but in the question we are asked to calculate the mass of the bottle when it is completely filled with alcohol. And we know that the mass of the bottle alone, okay, is 19 gram. Okay, and the mass of alcohol, according to our calculation, is 37.6 gram. So MA, which is mass of alcohol, plus the mass of bottle equals to 19 plus 37.6, and this will be equals to 56.6 gram. Okay, so let's move over to the screen to pick the correct option. So from our calculation, we got the mass of the bottle when it is completely filled with alcohol to be equals to 56.6 gram. Okay, so that makes option D the correct option, 56.6 gram. Do you have any question to ask? Please feel free to ask your question by clicking on the link in the description below, and this will take you to my school website. There you can ask all your questions and solution will be provided to you within a short period of time. Moving on to question 37. How much work is done against the gravitational force on a 3.0 kg object when it is carried from the ground floor to the roof of a building, a vertical climb of 240 meters? So let's move over to the board. Okay, we must not forget that work done against gravity, okay, work done against gravity is given as mgh, okay, where m here stands for mass, g stands for acceleration due to gravity, and h here stands for the height. So according to the question, the mass is 3 kg, so times acceleration due to gravity, if you are not given, make use of 10 meters per second square. So put 10 here times 240, okay, which is the height. Okay, so if we multiply, this will give us, okay, let us go 3 times this will give us 12, write down 2, carry 1, times this 7, then we have 2 zeros. Okay, so this we can put in joule, this is joule, but we can put it in kilojoule, and that will be divided by 1000. So in that case, we have 7.2 kilojoule. Okay, so let's move over to the screen to pick the correct option. Okay, so from our calculation, we got 7.2 kilojoule, which is option A. So option A is the correct option. Do you have better explanation or steps to any of these questions? Please share this information. All you need to do is to go to the comment section and comment the question number and the solution you wish to share. Question 38. A beam of light traveling in water is incident on a glass which is immersed in the water. The incident beam makes an angle of 40 degrees with the normal. Calculate the angle of refraction in the glass. So refractive index of water is equals to 1.33, while refractive index of glass is equal to 1.5. So let's move over to the board to solve that question. So we know that from Snell's law, okay, from Snell's law, we know that N1 times sine I is equals to N2 times sine R. Okay, where I here stand for, where N subscript 1 here stand for the refractive index of water, when N subscript 2 here stand for the refractive index of the glass. Okay, while I here stand for angle of incidence, while R here stand for angle of refraction. Okay, so from our question, we are told that angle of incidence, okay, is equals to, angle of incidence is equals to 40 degree, and the refractive index of water is equals to 1.33. Okay, refractive index of water, which is N1, equals to 1.33, while the refractive index of glass is equals to 1.5. Okay, so we just substitute these values into the given formula, so that we'll be having 1.33 times sine 40 is equals to 1.5 times sine R. Okay, so we make, since we are looking for arrow, so we make sine arrow the subject of formula. So that sine arrow is equals to 1.33 times sine 40 divided by 1.5. Okay, so this will be equals to 0.5700. Okay, so sine arrow is equals to 0.5700. Okay, but we are looking for arrow, not sine arrow. So we need to take the sine inverse of both sides. So that r is equals to sine inverse of 0.5700. And this will be equals to 34.75 degree. Okay, so let's move over to the screen to pick the correct option. So from our calculation, we got the angle of refraction in the glass to be equals to 34.75 degree. So that makes option D the correct option, 34.75 degree. Question 39. An open tube mercury manometer is used to measure the pressure in a gas tank when the atmospheric pressure is 101,325 Pascal. What is the absolute pressure in Pascal in the tank if the height of the mercury in the open tube is 25 centimeters higher? Density of mercury is given to us to be 13,600 kilometers per meter cube, and we should take acceleration due to gravity to be equals to 9.8 meters per second square. So let's move over to the board to solve that question. I think to solve this question, it's necessary for us to sketch the manometer. So let's try and sketch the manometer. Okay, so the height of the manometer, I think we are told that the height of mercury in the manometer is 25 centimeters. Okay, so we are asked to calculate the absolute pressure, okay, in the gas tank. But remember that atmospheric pressure will be one of the pressure that will be acting on the gas inside the tank, and mercury too is also exerting pressure on the gas. So in that case, absolute pressure, ABS, becomes atmospheric pressure plus the pressure exerted by mercury. Okay, and we know that pressure is equals to density, okay, times height times acceleration due to gravity. Okay, so these are for mercury. So we bring it here. So let's put it P-E-R-O-X. Okay, so in this case, we have that, but the pressure, according to the question, is given to us to be 101,325 Pascal, then plus that of the pressure exerted by mercury. So that would be, the density of mercury is 13,600 times the height of, so this we have to convert this to meter. Okay, we have to convert the height to meter. Since height is equal to 25 centimeters, we have to convert it to meter. So by dividing by 100, so that will be equal to 0, which is 0.25 meter. Okay, so that's what we are using here, so that all the units can be the same, 0.25 meter. Then times acceleration due to gravity, which is 9.8. So this becomes 101,325 plus 33320. If we multiply all this, that will give us 33,320. Okay, so if we add this together, our answer will be equals to 134,645 Pascal. Okay, so the absolute pressure in the mercury manometer is equal to 134,645 Pascal. So let's move over to the screen to pick the correct option. Okay, so from our calculation, we got the absolute pressure to be equals to 134,645 Pascal. So that makes option D the correct option. Question 40. The sensitivity of a thermometer is A, all of the above; B, how quickly a temperature change can be detected; C, the difference between the maximum and the minimum temperature; D, the smallest temperature change that can be detected or measured. So the answer to this question is option D. So the sensitivity of a thermometer is actually about the smallest temperature change that thermometer can detect or measure. Okay, so it's not option B, how quickly a temperature change can be detected, and it's not option C, which is the difference between the maximum and the minimum temperature. Okay, this is talking about range. or you can as well look at it as fundamental interval. Okay, so the correct option to this question is option D. I believe you are enjoying this video content. If so, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next video.